this is going to be a long one. So this is transformations. It gets a bit dicky. So it all bases around this y equals x squared thing. We want to talk about what happens when we add extra bits and pieces to that graph. So the first thing we're going to talk about is what happens when we multiply the whole function by a number. So I would suggest actually putting it in your calculator. So pause here, put it in your calculator, and make sure you get the right thing out. But what happens is, so this is my general graph, y equals x squared. And then if I multiply the whole graph by 2, I actually get same graph, just skinnier. And then if I multiply it by a half, I'm going to widen my graph out. So what's happening is we're changing how quick the gradient changes on my quadratic. And this is called the dilation. So we're dilating our graph. We're making it skinnier or fatter. And when you multiply the whole function by a number like we have here, the way we talk about it is the dilation by a factor of a, which means the number, in the direction of the y-axis, because we're stretching it up towards the y-axis. That's because if we considered when x is 1, for this graph here, that's a half. For this graph here, that's at 1. For this graph here, that's at 2. So we're really just changing the value on the y-axis when x is 1 or negative 1 to the number that we're multiplying the whole function by. Now this is on your cheat sheet. You don't have to remember these words. You just have to be able to find them on your cheat sheet and use the right ones. Okay, so if we actually multiply the x by a value instead, put it in your graph, have a look, see what happens. But you should come out. So we've got our general graph, y equals x squared. For this one, when we multiply by 2, it gets really skinny really fast. So even skinnier than when we did the whole thing by 2. And when we do it by half, it gets really wide really fast. So we're still dilating, we're just dilating faster. And when we multiply the x by a thing, we're actually dilating in the direction of the x-axis by a factor of 1 on a. So that's saying when I have my y value of 1 here, this guy is a half. This guy's at 1 and this guy is at 2. So for our second graph here, that has a 0.21. This one graph has a 0.51, which is just the number we're multiplying by on under 1, because a half divided by 1 and a half ends up as 2. So once again, you don't have to remember this, don't have to remember the 1 on a thing because it is on your cheat sheet. The one we focus on is the dilation in the direction of y anyway. You might get something here and there about the x-axis, but not often. Okay, what happens when we stick a negative in? So stick them in your calculator and see what happens. So we know our general graph is that guy. And hopefully you've figured out that in your calculator, that is the negative version of our graph. And it's the same if you do the other two. So we've got y equals 2x squared, and then y equals negative 2x squared. So what this is a reflection around the x-axis. Once again, on your cheat sheet, don't have to worry. But that's what this one's called. It's all about a reflection. It's just saying it's like looking at it in a lake pretty much, or the fact that we're wrapping our whole graph around the x-axis. Alright, and the last sort of transformation we can have. Stick them in your calculator, see if you can come up with it first. Hopefully what you've come up with is this. So what happens when we're adding a number or subtracting a number from our function is that we are moving the graph up and down. That's all we're doing. So if it's a positive number, we are moving it up. If it's a negative, we are moving it down. And these guys are called translations. So I am translating my graph 2 units up. I'm translating my graph 2 units down, that sort of thing. All right, so what do we think is going to happen? We have a positive and a negative inside the bracket. So now we're affecting the x. All right, so hopefully you stuck it in your calculator and you figured out this is what happens. So our graph stays the same shape, but we are moving it left or right. So these are translations left or right still. But the thing is, when we have a positive in the bracket, we are moving it left. That feels counterintuitive. That feels like the opposite of what we usually do. But we're thinking, what's the x value that makes that equal 0? X value that makes the bracket equal 0. So that's why with a positive number, we are moving it left, we're moving it down. So with a negative number, we are moving it right. Okay, so that is all the translations. Make sure you get transformations, sorry. Make sure you get them down, you write some sort of notes about them. The next video is about how we actually use that when we're graphing and such.